What's up, pre-calc? Today we're going to be talking about regressions. And so let's first start with the question that we see at the top of our note sheet. What is our ultimate goal with a regression, and when and why do we use regression analysis? We'll see this when we get more into our notes and like examples and stuff. But when we are talking about regressions, what our ultimate goal is to estimate. You should be following along, writing this in your notes as well, to estimate the relationship between an independent variable x, and a dependent variable y. Variable y. All right, and you'll see what I mean by that. We're, for the most part, just going to be dealing with data points and saying, hey, like, I believe there's a relationship between these two variables, within the data points that we were dealing with. I want to come up with some function or some relationship between the two so that I can use it to predict. And the two main types of regressions or relationships that we will be talking about are linear regressions, which of course is just a line, and then quadratic regressions, which is like our parabola. When we are doing examples in Desmos, the notation that you have is super important. And so I want us to write it here now so that we are ready to go with it once we actually start doing examples. When I'm doing linear equations, what I'm going to type in is y1 regress to, that's what this little symbol means, this squiggly, regress to, m times x1 plus b. And this should look familiar to us, right? Because we know the equation of a line in slope-intercept form is y equals mx plus b. That's exactly what we're doing here. When we were talking about quadratics, our equation is going to be a little bit different. y1 is regress to ax1 squared plus b x1 plus c. All right, and this was some of the nitty-gritty when it comes to regressions. And once we get into examples, we'll see exactly how this stuff applies. And so on the back side of our worksheet, we have an example. I'll give us a second to read it. And so we have a study comparing the speed, x, in miles per hour, and the average fuel economy in miles per gallon with the results shown in this table below. Again, our goal and kind of what this problem is saying, hey, like, the speed of our car and the fuel economy of our car, two completely different variables that we believe have a relationship to each other. We want to try and determine what that relationship is, or at least like estimate a good model for that relationship. And so let's start with letter A. We want to think about what seems to be happening in the table, and mainly like as our x values go up, what do we notice happening with our y values? What I notice when I look at this data is that as my speed is starting to get a little bit higher, but it's still pretty low, like we're at 15 miles per hour and 20 miles per hour, my fuel economy is pretty low. As I get to like higher and higher speeds and up around like 40, 45, 50, even 55, I kind of top out around a fuel economy of 30, and then as I start to get faster than 55 miles per hour, my y values start to go down. My fuel economy starts to go down again. And so being able to look at these numbers, and we'll see for letter B, we're going to graph these data points as a scatter plot so we can look at them. This is kind of going to help us give an estimation as to hey, do we believe that this would be better modeled by a linear function or by a quadratic function? Let's take a look at graphing these on a scatter plot to get a visual as well. whenever we are trying to graph data points, we are going to go up to this plus in the top left corner of our Desmos that says add item. And when we do, it gives us a few options. We are going to click on table. And we notice that when we do that, we get a column for X1 and a column for Y1. In our X1, this is where we are going to type in each of the values for speed that we have. And in our Y1 column, that's where we will type in each value for our fuel economy. I'm going to give us a second to do that now, but it's very important that if 15 is the first speed you put in that table, 22.3 has got to be the first Y value you put in the table as well. Our pairs, like these are data pairs, they have to stick together. So let's take a second and fill our data in our table in Desmos. Great, once we have all of our data in our XY table, if we scroll down to the bottom of like this table that we just plugged in, there is a magnifying glass with a plus in it. When we click that, it'll zoom us in so that we can see all of our data points. And what we notice again is like, ooh, we kind of see like a shape start to take place here. And this kind of makes sense based on what we were saying with our answer to letter A, right? Lower speeds and higher speeds give us lower fuel economy. And then kind of a mid-range speed is going to give us our highest fuel economy. And so, if we are trying to look at option C and make a prediction as to what type of function would best model this data, I want you to take a guess. Do we think we'd use a linear function to represent this data or a quadratic function? We're going to use a quadratic, of course. If we're looking at this data, there's no way that we can model this data with a straight line because this data curves, right? And we know quadratics curve just like this. And so we are going to create a quadratic regression to represent and model this data. How we're going to do that is I'm going to look at adding another expression. We'll do it number 2 underneath my table. And I'm going to type exactly what we have in our notes for a quadratic regression. Y1, and then the squiggly line, ax1 squared plus bx1 plus c. Let's go ahead and type that in. I'll do it at the same time here so we can make sure we got it. So y1, the squiggly line is in the top left corner of your keyboard. A x1 squared plus b x1 plus c. And what that is going to do for us is based on the data that we have here. Our calculator is going to create a quadratic that it believes best models the relationship between these two variables. And we see it like matches up pretty well, right? Most of these points fall pretty close to our quadratic. And so I'd say like our calculator can actually do a really good job at trying to estimate the relationship between two variables as long as we're like making accurate claims about what's happening. Right? There's sense in the fact that these two variables would be related. And so, part C for our worksheet asks us to write the equation that we get from our calculator. That is where we are using these numbers, A, B, and C, to come up with our equation as well. You should still have our calculator on your screen so that you can see those values. But when I write this equation, I'm going to have y equals my A value, which is negative 0.08 x squared. Let's check just to make sure. Nice. Plus 0.746x. Again, that is coming from my B value here, because my B is going in front of my x, 0.746x, plus 13.47. That is my C value, plus 13.472. And that is my regression equation for this data. Let's actually use the function that we came up with to answer some questions. So for letter D, we're talking about maximum fuel economy. And so, of course, I think we're experts at finding maximums on our graph. Where is it located? It's going to be the highest Y value. And we see that happening here at the top of our graph. And because we're talking about Y values, we're looking at this 30.441. And so when this third part, so highest Y value, or coordinate. Part 3 says find the maximum fuel economy on the calculator. Well, fuel economy is our Y value, and we just found that that maximum Y value was 30.4 miles per gallon. Nice, we just used our regression equation to help us answer a question and make predictions about our some of this data. And so we're going to do the same thing for part E. Using our calculators, using Desmos, using our regression equation, we want to make a prediction about how much fuel we would use. So it's like fuel economy. So what is Y? If you were going 42 miles an hour. 42 miles an hour is my speed. That is representing X. All right, and remember, if we have an X and we're trying to find Y in our Desmos activity from the past couple days, we know that we can find like f of 42, and that'll give us whatever our Y value is. Now, in order to do that in our calculator, we need to make sure that we are representing our regression equation as an actual equation in Desmos. And so what I'm going to do is I'm going to say, okay, f of x is equal to ax squared plus bx plus c. What that is doing for me is using the a, b, and c that I just came up with, but now it's actually graphing that as a function. We see here that we have like a red circle. That means it's the red function on our graph. That is exactly overlapped with the regression equation because we're literally copying down the same regression equation. Now that my f of x is defined, now I can type in f of 42 and I get my answer. What was the question asking? How much fuel would we use? We would use 30.3 miles per gallon. So f of 42 is 30.3 miles per gallon. Same thing if we were talking about when x is equal to 19. All I'm going to do is find f of 19. And I get 24.685. Okay. Last question before we head out. For what speeds is the fuel economy, which again represents our Y, greater than 27 miles per gallon? Whenever I'm giving a Y and I'm trying to find X, right, for what speeds, that means we're looking for X, I'm going to graph this Y as a separate equation. Y equals 27. And I do that. Super similar to a question we did yesterday in our calculator practice. We see that this horizontal line representing Y equals 27, our fuel economy, our graph, our function, is greater than that. Looks like from an X value or a speed of 25 miles per hour until a speed of 65.987 miles per hour. So let's go ahead and write that down. Again, we're looking at our X values because it is asking between what speeds is our Y value, our fuel economy, greater than 27. And I've gone ahead and written that response here. All right, this is good on our notes for regressions. We'll do more practice tomorrow. Thanks, folks.